So Newton's first law states that an object is moving at a constant velocity until acted upon by an outside force. So what I'm going to do is I'm going to push Andrew into the wall, and the wall is going to stop him because he's moving at a constant velocity, and something is going to stop his motion. So here goes.
This demonstration represents Newton's first law because I was at my rest state of motion, and Konrad was the force pushing against me to get me from my rest motion into my moving motion. I was moving at a constant velocity between the time when Konrad pushed me and when I hit the door, and the door was the force that made me go back to my rest position.
All right.
This is the second demonstration for Newton's first law. This demonstration represents Newton's first law because with me flicking the note card, I'm only putting a force on the note card, not the pennies. Since I'm not putting a force on the pennies stay at their rest state of motion and fall into the cup.
So Newton's second law is the equation is force equals mass times acceleration, and it says that the acceleration is directly proportional to the force acting upon the body, and the mass is inversely proportional. So we're doing Newton's second law, demonstration 1, part 1.
Demonstration 1, part 2.
Come on, go!
Molly.
This demonstration represents Newton's second law because my dog Molly needed more force to pull Konrad because Konrad's mass is heavier than mine. I have a ping pong ball and a soccer ball. I'm going to roll both at the same force. And since the ping pong ball weighs less, has a less mass, it's going to have a greater acceleration. This demonstration represents Newton's second law because the ping pong ball has less mass than the soccer ball, and if I roll them with the same amount of force, the ping pong ball will have a faster acceleration because its mass is lighter.
So Newton's third law states that when a body puts a force on a second body puts a force equivalent but in the opposite direction. Equation 1 for Newton's third law.
This demonstration represents Newton's third law because Konrad put a force on me and I put the same amount of force on him in an opposite direction.
And I was the action force, and Andrew was the reaction force.
This is demonstration 2 for Newton's third law. This demonstration represents Newton's third law because the red car is putting a force on the brown car, and then the brown car is putting the same amount of force in the opposite direction.
And the brown car is the reaction force, and the red car is the action force. So I have a ping pong ball and a soccer ball, and I'm going to roll both of them. And the ping pong ball is going to go faster than the soccer ball because it weighs less. I'm going to put the same amount of force.
Molly.